So as you have seen that I can write Ck as, don't write anything, just look at the board. Ck we can write it as mod of Ck e power j phi k. Yes or no? Ck is a complex number. I can write in the polar form as mod of Ck e power j phi k. So mod of Ck, if I expand this term, cos phi k plus j sin phi k. Can I write Ck, mod of Ck as Rk by 2? Can I write mod of Ck as Rk by 2? Yes. So cos phi k plus j sin phi k. Rk cos phi k. Rk cos phi k is Ak plus j Rk sin phi k. See, Rk cos phi k is Ak. Rk sin phi k is what? Minus Rk sin phi k is Bk. So I can write Rk sin phi k as minus Bk. So Ck is equal to Ak by 2 minus j Bk by 2. Ck is equal to Ak by 2 minus j Bk by 2. Ck is equal to Ak by 2 minus j Bk by 2. This relation is important. We have written that Ck, which is the complex Fourier series coefficient, is 1 by t integral f of t e power minus j k omega naught t. Yes or no? Ck is equal to 1 by t integral throughout the time period f of t power minus j k omega naught t dt. This is what we have written on the very first page for complex Fourier series coefficient. Now if you expand this term, 1 by t integral f of t cos k omega naught t minus j sin k omega naught t dt. So 1 by t integral f of t cos k omega naught t minus j 1 by t integral f of t sin k omega naught t. This is Ck. Now I can equate Ck is going to be equal to what? Ak by 2 minus j Bk by 2. So equating 1 and 2, let me consider this is 1 and this is 2. Equating 1 and 2, we get Ak is equal to 2 by t integral f of t cos k omega naught t dt, and Bk is equal to 2 by t integral f of t sin k omega naught t dt. If you know Ck, can you please tell me what is C naught? What is C naught? A naught, C naught, R naught, all are same. Right? So R naught, C naught, A naught, all of them we have equated. What is C naught? Put the value of k equal to 0. Put the value of k is equal to 0. It's 1 by t integral of t f of t dt. 1 by t integral of f of t dt. What we call this term is? If you remember, while discussing about average power signals, we have given a term for this. What is this term? Integrating, dividing. Integrating till t and then dividing by t. Very good. We call it as an average value or a mean value. We call it as a mean value. So the DC component, we know it can be called as a mean value. The DC component is what we call it. This is not a periodic signal. Huh? This is not, sorry, this is not the power. This is not the power. Power means if you have a square here, then it becomes an average power of the signal, right? If you don't have a square, it's nothing but a mean value. Right? So till now, whatever we have seen, the important things that we have discussed is, the first one is, if your signal is real, then the nature of CK satisfies even conjugate. CK satisfies even conjugate if f of t is real. Second thing that we have discussed is that if f of t is real and even, if the signal f of t is real and even, then bk is equal to 0. If f of t is real and odd, then a0 and ak values are equal to 0. F of t is real and even, its bk is equal to 0. If the f of t is real and odd, then the values of a0 and ak both will be equal to 0. And the next one is the relation that you have between ck, ak, bk. Ck is equal to ak by 2 minus j bk by 2. Ck is equal to ak by 2 minus j bk by 2. Okay. So these are the things, what is important we have discussed till now. Okay, these are the very important things that we have discussed till now. Very good, yes. If the signal is both real and even, then the nature of CK is real. Yes, of course, yes. If the signal is real and even, BK becomes 0, right? BK becomes 0 and the value of CK is AK by 2, which is a real number. Of course, absolutely correct. The question is that the real valued signal refers to real amplitude. Yes, of course, absolutely correct. Yes, Gagan, I completely understand. Yes, it is slightly tougher, but don't give it up. Huh? Don't give it up, because you keep on listening to what is going on in the class. Slowly you will become comfortable, and our aim here is that to solve the gate problem, right? And to solve the gate problems, we should have a basic knowledge of the Fourier series. So if you don't have that basic knowledge, it's very difficult to encounter the questions from Fourier series. Let me tell you, the content from which the Fourier series questions are going to be asked in gate exam will be very limited. Okay, we don't have such a big content from where you can have diverse number of questions. The content will be very limited. Okay, and we completely easily understand from where the questions are going to come from, how the questions will be framed, where the questions are going to come from. Is everything very clear in the case of Fourier series? Okay. The only thing is that the questions in Fourier series are slightly tricky. Okay, it means that they are more logical. So when the questions are more logical, we have to solve more number of questions. Okay, ideally we have to solve all the gate questions which have been asked in previous years, so that we can become comfortable in this particular topic of Fourier series. Okay, as of now, yes, whatever we have gone through for the last 2 hours, yes, it is a little bit slightly more boring. Okay, we are having more mathematics. But yes, that particular part is like that only. From now onwards, we will be having completely the problems and the gate problems. Okay, we will be seeing the example problems, and then we will go for properties, and then we will go for the gate problems. Okay, so there is a question here. So what is this term? What is this? Very good. So this is what we call as the impulses, right? So we are having periodic impulses. We are having periodic impulses, the train of impulses, yes, the train of impulses. So these impulses are repeated, periodic, with the fundamental time period of capital T. Fundamental time period of capital T, and we have to see its CK. Now once you know CK, you know all the frequency components of the signal. Once you know CK, then you know all the frequency components of the signal. So what is this A? Is this A the amplitude or the area? Is this A the amplitude or the area? This A is the area. Very good. So this A is not the amplitude, this is the area, because we know the amplitude in the case of the impulse is going to be infinity only. The amplitude in the case of impulse is going to be infinity only. So I have to find the value of Ck. I have to find the value of Ck. What is Ck? Ck is equal to 1 by t integral t f of t e power minus j k omega naught t. Let me consider the interval of t from minus t by 2 to t by 2. If I consider the interval of t from minus t by 2 to t by 2, minus t by 2 to t by 2, and in this interval of minus t by 2 to t by 2, what is f of t? Forget about everything. Between minus t by 2 to t by 2, what do you have as f of t? What is f of t? Between minus t by 2 to t by 2, what is f of t? Can I write it as a? What is the meaning of a? From minus t by 2 to t by 2, if I write it as a, it means that it's constant and the value is a. So we should not say it as a. A means this. Minus t by 2 t by 2, the value is a. But it is not like that. It is a into del of t. It is an impulse which is present at t equal to 0. It is an impulse which is present at t equal to 0 and having the area of a. Correct or not? So we can write it as a into del of t in the region of minus t by 2 to t by 2. In the region of minus t by 2 to t by 2. Okay, so what I'll do here, 1 by t integral minus t by 2 to t by 2, the value of f of t is a into del of t. So del of t e power minus j k omega naught t. Now you are having something called as del of t multiplied by some function of time. Go back and tell me, what is f of t multiplied by del of t? Some function of time multiplied by del of t. So there is a question that why are we considering minus t by 2 to t by 2? Why are we considering minus t by 2 to t by 2? It is because you can consider a single period of t. And this t can be from 0 to t. You can also take it from minus t by 2 to t by 2. Any point, if you are taking a single period, that is fine. So here in this case, I am taking it from minus t by 2 to t by 2. F of t multiplied by del of t. Multiplication, it's not convolution. Huh? When you multiply, what will happen? The impulse is present at t is equal to 0. So you will be having a sample of the signal at t equal to 0. You will be having the sample of the signal at t equal to 0 multiplied by the impulse itself. So it is f of 0 multiplied by del of t. It is f of 0 multiplied by del of t. So even if you write f of 0, it is wrong. If you write it as f of 0, it is wrong. You have to write it as f of 0 multiplied by del of t. The transformation of impulse there we have learned, right? F of t multiplied by del of t is equal to f of 0 multiplied by del of t. It's very, very important. We have discussed that. Right, so I can put t equal to 0 here. I can put t equal to 0 here. So if I put t equal to 0, this term becomes 1. So a can come outside. If a can come outside, integral minus t by 2 to t by 2 del of t dt. What is this term? Integral minus t by 2 to t by 2. This value is going to be 1. Okay, even if you take the value, even if you take the region from 0 to t, still it is going to be del of t only. Even if you are taking from 0 to t minus t by 2 t by 2 or 0 to t, you are going to have del of t only. Right. So we get the value of Ck. We get the value of Ck as a by t. We get the value of Ck as a by t. Okay, so if you are having the series of impulses, the value of Ck is going to be a by t. The values of Ck is going to be a by t. So I can write Ck a by t at omega naught it's a by t. At 2 omega naught, it's a by t, and so on this side also. Okay, so the question is that how between 0 to t also you are taking it as a into del of t. I told that if you are taking the region of minus t by 2 t by 2, also you are having a single impulse. If you are taking the region of 0 to t, also you are having a single impulse. Please understand one thing, that in one single period, how many impulses you are having? If you are taking a single period, one you are having. See, what is the meaning of single period? I'll tell you. You are starting at 0 minus till t minus. This is one period. Or if you are starting from 0 plus till t plus. Okay, so if you are taking a single period, complete period, you will be having a single impulse. Any period you are taking, you will be having a single impulse. So to avoid that confusion, see, if I am taking it from 0 to t, you will get a confusion that you are having two impulses, but actually you are having only one impulse. Because if you are taking a one single period, you will be having only one impulse. That is what we are seeing here. So to avoid that confusion, only I have taken from minus t by 2 to t by 2. Okay? So every time when you are considering a period, you have to have a complete period. So you are either starting from 0 minus to t minus, or 0 plus to t plus, or comfortably you take it from minus t by 2 to t by 2. Okay, so Ck in this case, what is the nature of Ck we got? Please answer, is it real? The Ck that we got, is it real here? Very good, it's purely real. Is it even? The Ck that we got here, the Ck spectrum we are having here, is it even? What is the meaning of even? Whatever information you are having on the right side, the same information is present on the left side. See, because it is discrete in nature, I can also write a sequence-wise representation. I can also have a sequence-wise representation. Because it is discrete, every time you are having a discrete, I can have a sequence-wise representation like this. This is a k equal to 0. So whatever information you are having on the right side, exactly same information you are having on the left side. So it is nothing but even. So I can say that the nature of Ck is real and even. Ck is real and even. Ck is real and even. Why you are getting Ck as real and even? We will always get Ck as real and even when f of t is real and even. When f of t is real and even. This is always the case. If f of t is real and even, then Ck will also be real and even. If f of t is real and even, then Ck will also be real and even. Then Ck will also be real and even. The nature of the signal is odd, right? The nature of the signal is odd. Now we will have the same approach. Ck is equal to 1 by t integral through the time period f of t e power minus j k omega naught t. So 1 by t integral, you are starting from minus t by 2 to t by 2. Minus t by 2 to t by 2 f of t e power minus j k omega naught t dt. So what is f of t? F of t is equal to minus a for the value of t between minus t by 2 to 0, and it is equal to plus a for the value of t between 0 to t by 2. The f of t is equal to a minus a between minus t by 2 to 0, and from 0 to t by 2 it is nothing but plus a. So what I will do here, I will substitute here 1 by t integral minus t by 2 to 0, the value is a minus a into e power minus j k omega naught t dt, and between 0 to t by 2 it is plus a e power j k omega naught t. So minus a comes outside, minus a by t, e power minus j k omega naught t divided by minus j k omega naught t, minus t by 2 to 0, and here also a by t, if I take it as common completely, here there is a minus sign, and here it is going to be e power j k omega naught t divided by j k omega naught, 0 to t by 2. So a by t, if I substitute here, it becomes 1 here. Let me take j k omega naught t outside. I'm sorry, here also there is a minus, minus and minus. So minus of minus here becomes plus, and here this becomes minus. Let me bring out j k omega naught outside. So it becomes j k omega naught t. I'm sorry, capital T. So here, if I put 0, it is 1. Minus, if I put minus t by 2, it is e power j k omega naught t by 2. Minus, if I put t by 2, it is e power minus j k omega naught t by 2. If I put 0, it is 1. So, can you please tell me what is the relation between capital T and omega naught? What is the relation between capital T and omega naught? Omega naught is equal to 2 pi divided by capital T. This is something we have learned, where capital T is the fundamental time period, omega naught is the frequency. Then what is the value of omega naught multiplied by t? So wherever you are having omega naught multiplied by t, you can put 2 pi. Wherever you are having omega naught multiplied by omega naught multiplied by t, you can put 2 pi. Substitute everywhere you are having omega naught multiplied by t. So a ck is equal to a by jk 2 pi, and here it is 1 minus e power 2 pi divided by 2, it becomes pi only. So jk pi minus e power minus jk pi minus 1. So it is a by j 2k pi. This becomes 2 minus, take minus as common, it becomes e power jk pi plus e power minus jk pi. So you are having something like e power j theta plus e power minus j theta. If I divide and multiply by 2, if I divide and multiply by 2, what is this term? What is this term? Cos, very good. So 2 over here and 2 here gets cancelled out. So a by jk pi 1 minus cos k pi. This is ck. ck is equal to a by jk pi 1 minus cos k pi. So if I take j to the numerator, this becomes 1 by j is nothing but minus j. So minus j a by k pi 1 minus cos k pi. Now let me take the values of different values of k. Let me take the different values of k. K is equal to 1. If I take k is equal to 1, can you please tell me what is the value of C1? If I take k is equal to 1, what is the value of C1? Minus j a by pi. Here it is 2. C1 is equal to minus 2ja by pi. C1 is equal to minus 2ja by pi. Okay. So k is equal to 2. If I take k equal to 2, what is the value? If I put k equal to 1, cos pi is minus 1. So totally it becomes 2 here. So it is minus 2ja by pi. 2ja by pi. If I take k equal to 2, cos 2 pi is 1. 1 minus 1 is 0. If I take k equal to 3, then what is the value of ck? If I take k equal to 3, then what is the value? Minus ja by 3 pi. It is not C1 because k is present here, right? So k is equal to 3. In the first case, k was 1. Here it is k equal to 3. Cos 3 pi. Cos 3 pi is 1, again minus 1. Cos 3 pi is again minus 1. So it becomes 2. So C3 is equal to minus 2ja by 3 pi. Minus 2ja by 3 pi. This is C3. Next is C4. C4 will again be equal to 0. Can you please tell me what is C minus 1? C minus 1. We know that whenever you are having a signal which is real, Ck satisfies even conjugate property. So if it satisfies even conjugate property, arrow is here. You know the terms which are present on the right side. Minus 2ja by pi, 0, minus 2ja by 3 pi. When Ck satisfies even conjugate property, what will come here? 2ja by pi, the conjugate of it. The same term with a conjugate. Here also the same term, 0, the same term with a conjugate. What is the value which is present at k equal to 0? Can you please tell me? What is the value which is present at k equal to 0? Ck is equal to minus 2 ja by k pi 1 minus cos k pi, right? If I put k equal to 0, here it is 0, here also it is 0. So what I will rather do is that I will be using, whenever k is equal to 0, I will not use this formula. This is only for k not equal to 0. C naught is equal to 1 by t integral minus t by 2 to t by 2 f of t dt. If you integrate from minus t by 2 to t by 2 and then divide by t, that is nothing but C naught. First tell me, if you integrate from minus t by 2 to t by 2, what is the value? If you integrate from minus t by 2 to t by 2, what is the value? See, here whatever is there, here exactly the same thing is there. Totally it is going to become 0. So C naught value is 0. See, let me bring the j's outside. All the j's which are present inside, let me bring it outside. Then here it is 2a by 3 pi, 0, 2a by pi, 0, minus 2a by pi 0 minus 2a by pi 3 pi में 0. Forget about j. Forget about j. What is the nature of ck now? What is the nature of ck? Just forget about j. If you forget about j, this is nothing but odd. And you are having j. You are having j. So it is imaginary and odd. So ck is imaginary and odd. Okay. So when are we going to have ck nature as imaginary and odd? When do we have the nature of ck as imaginary and odd? We will be having the ck always as imaginary and odd whenever the signal is going to be real and odd. Whenever the signal is going to be real and odd. Okay. So please keep a note and write down. Please keep a note and write down. Please keep a note and write down. If the signal f of t is real and odd, if the signal f of t is real and odd, if the signal f of t is real and odd, if the signal f of t is real and odd, if the signal f of t is real and odd, then the nature of ck is imaginary and odd. Then the nature of ck is imaginary and odd. Then the nature of ck is imaginary and odd.